Good morning. I am Joshua of High 2E. The problem that I will answer for today is a mooncake is cylindrical form of a radius 4 centimeters and height 3 centimeters. Some mooncakes of this size are packed into a closed rectangular box measuring 40 cm by 16 cm by 6 cm. So the first question is to calculate the volume of one mooncake. In order to find the volume of one mooncake, you have to multiply 4 squared to 3 and 2 pi, which will be equal to 48 pi. If you would convert pi to the standard form, it would be 150.79 cm cubed. So 150.79 cm cubed would be the answer for number 1. The question for number 2 is, at most, how many such mooncakes can be packed in the box? 3,840 divided by 150.79 would be equal to the mooncakes that can be packed. And the answer to this is 25 mooncakes can be placed in each box. When the box is filled with mooncakes, find the volume of the empty space in the box. Uh, 150.79, which is the volume of one mooncake, to be multiplied to 25, which is the capacity of one box. Then this would be equal to 3,769.75. 300,769 is the total, and we have to subtract this from the space of the box, which is 3,840. So it will become 3,840 subtracted to 3,769.75. And the answer that we will get here is the empty space in the box is 70.25 cm. If the mooncakes are to be wrapped individually, how many wrapping materials are needed? The surface area of the box is equal to 2 pi r squared plus 2 pi RH. 2 multiplied to pi, then multiply it to 4 squared plus 2 pi multiplied by r and 3. The answer will be 56 pi. And then last, can a new box measuring 32 by 10 cm by 12 hold as many mooncakes as the original box? The box can also hold the same 3,800 numbers of mooncakes because they have the same volume. So to get the volume of the new box, it would be 22 multiplied by 10 by 2, which will be equal to 3,840, which is the same as the previous box.
Yeah, good afternoon. I'm Carlo Mendoza of High 2C. I'm the group mate of Joshua Tsoi. So our second problem is a solid consists of a cone, a cylinder, and a hemisphere. The base radius is 4 centimeters. The ratio of the volume of the cone, cylinder, and the hemisphere is 6, 27, and 4, respectively. Find first the height of the cone, second, height of the cylinder, third, volume of the solid, and fourth, surface area of the solid. So basically, for the first part, we're looking for the height of the cone. So the formula for the volume of the cone is pi, 1/3 pi r squared times height. And that's equivalent to 6. So we substitute the values that we know. So that's 4 as the radius. After that, we multiply it by 3 so that the 1/3 gets cancelled. So this becomes pi 16 times height is equivalent to 18. After that, we start to divide everything. So if you divide it by pi, it's gonna be 16 times height equals 5.73. After that, the final step is by dividing each by 16. There's going to be 1/16 and 1/16 for the other side as well. The final answer will be height is equivalent to 0.36 centimeters. So let's move on to the next question. The height of the cylinder. So the formula for the height of the cylinder is pi r squared times height, and it's going to be equivalent to 27. Like what we did to the cone, we have to substitute the values that we know. So it's pi 4 squared times the height, it's equivalent to 27. We divide each by the pi, so it's going to be 1/pi, then 1/pi. It's going to be 4 squared times height, equivalent to 8.60. And final step is by dividing it by 4 squared, and that's 16. So 1/16, this gets cancelled, and this one divided by 1/16 as well. It's going to be height is equivalent to 0.54 centimeters. So the third question is, what is the volume of the solid? Taking that 6 is equivalent to the volume of the cone, there, and 27 the volume of the cylinder, and 4 as the volume of the hemisphere. If we add that all up, it's going to be 37 centimeters, cubic centimeters. So our final question is, what is the volume of, the surface area of the solid? Taking that, this is the cone, this is the cylinder, this is the hemisphere. There. So it's gonna be, for the cylinder, we're just gonna get the sides. So the formula for that is 2 pi r h. For the cone, minus the base, we won't take the base. So it's gonna be pi r l. L meaning the slant height. And for the hemisphere, since it's only half, it's gonna be 2 pi r squared. So first we have to get the slant height for the cone. The slant height is the hypotenuse of the the cone. Like if we make a right triangle. So the slant height, the formula for the slant height is a squared plus b squared equals c squared. So in this case, it's 0.36 squared plus 4 squared equals L squared. So this is slant height, this is the radius, or the base for the triangle, and this is the opposite of the hypotenuse. So if we square that, it's going to be 0.13 plus 16 equals the square of the slant height. So 16.13 equals slant height squared. So when we take the square root of 16.13 and square root of slant height, it's going to be 4.02 equals the slant height. The work calculator. Can I work calculator? Okay. So yeah, we got the calculator, and it's gonna be, the formula for the cone is gonna be pi, the radius 4, and 4.02. We multiply this, and it's gonna be 4 times 4.02, 16.08 pi. So for the cylinder, it's going to be easier because we have the height and the radius. So it's going to be 2 pi radius, which is 4, and the height, which is 0.54. That's going to be 16.24 pi. 4.32 pi. And for the last one, for the cone, we're just gonna multiply 2 pi r squared. It's gonna be 2 pi times 16, so 32 pi. For the final answer, you just need to add 16.08 pi, 4.32 pi, and 32 pi, and we solve. So the final answer for that is 52.40 pi. Since pi equals since pi equals 3.14, we multiply 52.40 by 3.14. The final answer is going to be 164.54 centimeters square. That's only an estimate since we didn't take pi as a whole and we're just rounding off to the second decimal point.